Hello, and welcome to this webinar on the latest developments in human body model positioning using the Oasys LS-DYNA environment. My name is Ghulam Mohammed, and I'm one of the application engineers at Arab, and I'll be taking you through today's session. Before we start, I want to mention that all of our webinars are recorded and available to watch on our Oasys website and YouTube channel. If you're joining me live today, you'll see that you're muted, but if you have any questions during the webinar, then please type them in the chat box and I'll do my best to answer them towards the end. If you're watching this on our YouTube channel, then please feel free to post a question in the comments box below or get in touch with your local distributor using the contact details provided at the end of my presentation. So the objective of this webinar is to demonstrate the latest positioning tools in Oasys PRIMER to achieve realistic articulation and positioning of human body models, preparing them for simulation-based positioning analysis. I'll be presenting several case studies to demonstrate the positioning workflow and the applications of these tools. This webinar is aimed at engineers working in the fields of passive safety and biomechanics. So let's start by introducing the Oasys LS-DYNA environment. Many of you will of course be familiar with the core suite of products. We have Primer, our preprocessor for LS-DYNA. We have D3plot and THIS for visualizing and processing your results. We also have Reporter for automatically producing reports and presentations. All these tools can be used with any LS-DYNA model, whether it's a small drop test model or a set of complex automotive models encompassing different load cases. We also have some other tools you may be less familiar with in your day-to-day work. We have Shell, a comprehensive LS-DYNA submission tool, which also provides functionality for running our applications in different ways. For example, automatically post-processing multiple analyses in one go. We have scripting capability embedded across all applications, which makes it easier for you to automate and customize. We have D3plot Viewer, our web-based lightweight results viewer for communicating results. And this is now joined by Report Viewer, which provides an easy and convenient way to share reports. The Oasys tool aims to provide you with all you need to produce quality models and in turn quality results, to give you the insight you need to collaborate effectively, make less mistakes, and to do all those things quicker. The focus of today's webinar is on a specific area of our Oasys tools, which is quality crash and safety models. So I just want to say a few words on crash and safety. Our LS-DYNA preprocessor Primer provides a comprehensive solution for crash and safety applications using LS-DYNA. We have many tools that aid you in setting up and post-processing your models, as you can see here. Now, as a bit of background, I just want to mention some of these occupant safety tools we have in Oasys Primer, because that'll feed into my later slides. We have tools for the creation and fitting of seat belts, including fully fabric belts through explicitly meshed slip rings. It's also worth noting that these tools include creating seat mechanisms, which allows you to easily move your seat into different positions. Our Seatsquash tool allows you to easily deform seat forms to remove initial penetrations between the occupant and the seat. We have a powerful airbag folding tool available as an optional plugin to Primer. This is called J-Fold. Our dummy positioning tools allows you to position an occupant easily in a number of ways. And we have extended our positioning tools to human body models with the aid of pre-configured positioning tree files. These tree files and tools allows users to interactively achieve realistic articulation and positioning of human body models, which is the main topic of this webinar. So I now want to focus on simulation-based positioning of human body models using Oasys Primer. Simulation-based positioning is a method for positioning a human body model with the aid of LS-DYNA. This method uses a system of cables between nodal pairs to pull the human body model into position. Now, you often run this before the main analysis, for example, a crash event. So why would you use simulation to position a human body model? Well, one of the main reasons is that you can avoid initial penetrations that can often occur between assemblies during preprocessor positioning. Also, during the positioning analysis, the simulation takes into account all the complex internal material properties and contacts that are defined in the occupant and seat model. And this makes simulation-based positioning much more realistic. Here we have an example of a positioning analysis. These have been easily created in Primer and then run in LS-DYNA. You simply specify your target positions, and Primer creates the cables required to pull the occupant into position within the analysis. Now, positioning of human body models in Oasys Primer involves using a tree file. A tree file in this context is simply a collection of ordinary LS-DYNA entities, but with extra data that defines how parts of the body are connected and in what order. It is this tree file that allows you to position human body models within the Oasys Primer software. So what we've done is separate the human body model into assemblies, and these assemblies are then connected into a hierarchy with a strict parent and child relationship. And the joints between the assemblies have appropriate properties and stop angles to ensure realistic articulation of joints. Primer positioning tree files have been developed for the most popular industry-leading human body models, such as thumbs and HBMs. So let's explore how to set up a positioning analysis in Oasys Primer using the example of positioning a thumbs average male occupant model on a mountain bike. Before I do, I just want to say a few words about the thumbs version 7 model. It's an enhancement of version 6 with significant improvements for injury simulation of occupants seated in reclined positions. It features 3 muscle activation levels: sleeping, or no muscle activation, normal, and braced. This model represents an average adult male and consists of approximately 2 million elements. Now, the basic workflow is as follows. First, the original thumbs model is read into Oasys Primer along with the corresponding tree file. Target positions are then defined using Oasys Primer's positioning tool. This may involve, for example, moving the hands onto the handlebar and feet onto the pedals. Once everything is defined, Primer automatically creates the cables to pull the human body model into position. Once the model has been created and run in LS-DYNA, the positioning analysis results are obtained along with a DYNA-in output file containing the deformed nodal coordinates. And finally, the deformed nodal coordinates from the final state of the analysis are imported back into the original model as input to the main analysis, for example, a crash event. So let's break this down further. The first step of the positioning workflow is to read the unmodified thumbs version 7 occupant model and add the corresponding primer tree file to the main keyword input deck to enable positioning. Now, it's important to note here that the contents of any primer tree file, such as the direct definitions, are configured based on the posture and label numbering of the original human body model. For this positioning exercise, I've also turned off muscle activation by replacing the default relaxed muscle include file with the sleeping condition or no activation include file. So the next stage is to specify the target positions. To do this, click on Tools and then Safety, and then select the HBM and Seatsquash button. A panel will appear prompting the user to select the desired analysis type and number of stages. In this example, we're going to set up a simple positioning analysis. The next few menus will guide you through the entire positioning workflow. Now, for a more detailed walkthrough of the panel, please refer to our quick start video tutorial on our Oasys website. For now, however, I'd like to highlight some new features we've introduced in Oasys Primer, as well as drawing your attention to some other useful features. In the HBM positioning panel, you'll notice that a new visualization table has been introduced in Primer version 20, making it easier to visualize and customize the visual properties of the different parts of a human body model when positioning. Visual entities are automatically categorized by assemblies or anatomy. Here I'm selecting the outer skin and bone structures. Now positioning can take place by any combination of three methods. Using the Rotate Angles tool, assemblies are rotated back their parent joints, 1 degree of freedom at a time. Assemblies below the current one is moved as a rigid unit. Moving on to the drag assembly mode, limbs can be interactively picked and freely dragged, and all the unrestrained parts will follow, subject to the limitations of the joints. Here I'm dragging the feet onto the pedal. The current rotations of each joint can be saved to a dummy angles file or a DEF file, which can be saved and read back in at any time during the positioning workflow. I'm now going to read in a DEF file from a previous Primer session. Here the angles are applied to each assembly in turn, working down the assembly tree from the root, repositioning the model to the previously saved configuration. Now we have also added the option to mirror the position of a human body model, making it easier to have a reflected position in the arms and legs. This will mirror assemblies which have an opposite matching sibling assembly. Once the target position is defined and accepted by the user, Primer automatically creates the cables and a new model. After positioning, Oasys Primer attaches up to 3 cables to stiff parts of each assembly. The cable properties are automatically calculated based on their length to ensure that the model is pulled into position in the specified time. The cable properties also include a shrink and settling time, which can be set by the user. Once the model has been created and run in LS-DYNA, the positioning analysis results are obtained. The stage construction keyword is used to define the number of positioning stages. In this example, we have a single stage analysis where one set of cables are moving the thumbs model into the target position. Once complete, the analysis produces a DynaIn file for each stage of positioning. This file contains the new deformed nodal coordinates and initial stress information from the analysis. The DynaIn file can now be imported back into the original model using Primer's Node Import tool. In version 20, we have introduced 2 additional options in the Node Import panel to address common issues and errors found when using a repositioned model for the main analysis. One of these options relates to 1D slip rings, and the other to joint angle parameters. So I want to say a few words about slip rings. Slip ring elements are used within human body models to model certain things like muscles and ligaments. If you're familiar with 1D slip rings in LS-DYNA, you will know that the definition requires you to define the seatbelt element on either side of the slip ring. So what happens during positioning is that the seatbelt elements pass through the slip rings, which means that the slip ring will now refer to the wrong element IDs. So for the final position, the slip ring definition has to be updated to account for the new seatbelt elements, now on either side. Primer now has an option to automatically do this. Once the node import step is complete, the final posture from the pre-simulation run is ready for the main crash analysis. I now want to say a few words about linked mechanisms, which is new to Oasys Primer from version 20. Historically in Primer, mechanisms and human body model definitions have been allowed to work together, but in a rather restricted way. The one-way parent-child relationship was not suitable when considering more complex connectivity between a human body model and mechanism constructs in Primer. To explain this better, let's come back to the thumbs on a bike example. In a situation such as this, where moving the handlebars must also move the arms, and rotating the pedals must also move the legs, the mechanisms and thumbs assemblies must be equal siblings, with no parent-child hierarchy. So what we've done is converted the thumb's definition into a mechanism and connected it to the bicycle in 5 places. 2 hands on the handlebars, 2 feet on the pedals, and buttocks on the seat. This animation shows how the thumbs model is now connected to the bicycle, and that rotating the left foot also rotates the pedal crank, and therefore the right leg as well. Both thumbs and bicycle now form a single mechanism in which movement of any component can influence any other. These linked mechanisms can be used to drive a multi-stage positioning analysis, where multiple intermediate positions can be defined. Hopefully you can see it is now easy to combine mechanisms such as bicycles with human body models to achieve more realistic positioning. This linked mechanism can now be used to set up multiple angles of pedal rotations to drive the motion of the legs. This in turn can drive a multi-stage positioning analysis, where a sequence of different feet leg positions can be achieved in a single LS-DYNA run. Here, Primer has created multiple set of cables in series and written out the DynaIn file to the end of each intermediate stage. This approach allows the user to specify several different end positions in one analysis, so slightly different positions can be achieved without having to go back and redo much of the initial part of the analysis. For inspiration, here are some other examples and applications of combining human body model definitions with mechanisms. Now let's take a look at an example of using the combined Seatsquash and positioning tool in Primer to set up an average male occupant HBM model in a front sled model. In this scenario, Primer can be used to automatically set up an LS-DYNA analysis to position the HBMC model and then squash it into a seat as shown here. The positioned occupant has now been fitted with a 3-point seatbelt model, featuring a fully fabric seatbelt system with explicitly meshed slip rings. An acceleration put has been applied to the said model, and the results of the analysis are shown here. Finally, I want to take a look at how to achieve a complex posture, such as an emergency braced posture of an aircraft occupant, using Primer's multi-stage positioning tool. A brace position for passenger and crew members in aircraft with forward-facing seats, equipped with a lap strap, is to bend forward, rest the head and chest against the upper legs, and wrap the arms behind the legs. Now, trying to achieve such a complex posture with one set of cables, in other words, a single stage analysis, would be too cumbersome to set up and might induce undesirable instabilities to the model. A solution to this problem is to split the posture into intermediate stages using multi-stage positioning tool. So what we've done is divide the final brace position into a series of intermediate and more manageable stages, where each stage is addressing one aspect of the posture at a time. So here we're looking at the results animation from a multi-stage positioning analysis. You can see here that there are many cables in series for the various stages. Once the first final position is reached, the analysis proceeds to the next position, and so on. Here is the same animation, but with different visual settings applied. So here's a summary of all the emergency brace postures that can be achieved using Oasys Primer. We are now coming to the end of my talk. So in summary, why use Oasys PRIMER for human body model positioning? First of all, realistic articulation and positioning of human body models can be achieved using Oasys PRIMER, ready for simulation-based positioning analysis in LS-DYNA. Secondly, we support the most popular industry-leading human body models on the market, including thumbs, GHBMC, hands, SAFER, and there'll be more to come in the future. Finally, the trees are freely available to all LS-DYNA users. Many of our customers are now successfully using them, improving their workflows and achieving higher quality LS-DYNA models as a result. So if you want to give them a try, then please get in touch with your local Oasys distributor for more information. I just want to add that we support the most popular thumbs models, including the version 7 family of models. And we also support the new version 7 seatback recline models. Finally, we support the most popular and latest GHBMC family of models as shown on this slide. And this includes both the detailed and simplified variants. I'd like to conclude my talk on where you can get more information and stay up to date on the latest developments. You can keep up to date with Oasys LS-DYNA news by signing up to our newsletter, visiting our website, signing up to our social media channels, or visiting our YouTube channel. So thank you again for your time and attention today. I hope you've enjoyed this presentation, and please get in touch if you have any questions. Thank you.